Find each angle measure to the nearest degree. What they're asking us to do is find each of these three letters. Here's the problem for each of these three letters. There is a trig function in the way. Sine is in the way, cosine is in the way, tangent is in the way. So I have to get rid of each of these trig functions legally. Now, the way I do that is I use the inverse trig function. So what I'm going to do is I'm just going to rewrite this guy, give myself some space. I'm going to have to do that with all three of these. Okay. And I'm definitely going to need a calculator for this one. You guys can't do these on your own. Back in the day, people had to use slide rules. Those were a nightmare. Now, my issue currently, all I did, by the way, was rewrite that. My issue currently is sine is in the way. You can't divide sine from both sides. What you do is you take what's called the inverse sine. Some people call this the arcsine, same thing. Inverse sine. What the inverse sine does to a regular sine is it gets rid of it. Okay, so now b is all by itself. The problem is I have to go to a calculator and find out what the inverse sine of 0.4848 is. So if you're using like a TI-84 Plus, you're looking for that inverse sine button. If you're using Desmos, you have to hit functions and use that button. So I'm actually going to go off to the side here, use my Desmos, and I'm now typing in, I'm not typing in anything, I'm hitting the inverse sine of 0.4848. Make sure your calculator is set to degrees. There's something called radians that looks like RAD. You don't want that. Even though it sounds cool because it's rad, you don't want that. Now, I typed it in my calculator, and I actually think I'm set to radians. I am. So I made it degrees. And according to this, I have 28.999, and it wants me to round it to the nearest degree. So 28.999 is 29 degrees. Okay? So what that means is if I were to run to a calculator and type out what's sine of 29 degrees, I would get 0.4848, blah, 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 blah. It's never going to be a nice number most of the time, unless you're dealing with like zeros and 90 degrees and stuff like that. But most of the time, it's going to be very unpleasant. I'm going to write this guy again, cosine A, leave myself some space, 0.7431. In order to get rid of cosine, I have to inverse cosine. Some professors, some teachers call that arcsine. Inverse cosine, both sides. That crosses the coses out. And I run to a calculator. I type out inverse cosine of 0.7431, and I get 42.0038, so I'm going to go with 42 degrees. Okay? Same thing here. All right, I'm going to write out tan W equals, give myself some space, 19.0811. In order to get rid of tan, I'm going to inverse tan both sides. So inverse tan. That gets rid of tan. Some people call that arctan. And now W is going to equal whatever the inverse tangent of, what was it, 19.0811. I get 86.99999. 86.99999 is awfully close to 87 degrees. Now, I am on an iPad using a Desmos app. Make sure, whenever you're in geometry class, pre-calc is a different story, but when you're in geometry class, make sure your settings, like you might have to hit that little wrench thing, make sure your settings are set to degrees. Okay, it says it right there. If you use radians, you're going to get a very small number every time for this. Maybe not too small for that, but you're going to get a very small number. If you're using like a TI-84 or like a Casio or some kind of smart calculator, graphing calculator, it might say something like rad next to degrees. Like if you hit the mode button, it'll probably say rad in degrees. You want the degrees. Okay, so make sure your calculator is set, but that's how you do it. If you are told sine of an angle equals stuff, inverse sine it, inverse cos it, inverse tan it, and you'll get that. Dunzo.